my great students of Master's Vessel Classical Academy, I welcome you to this chemistry series. I hope you are keeping safe, especially in the situation we have found ourselves in our country and in the world altogether. I hope you are washing your hands, you are equally keeping self-distances, you are using your sanitizers effectively to ensure that you are safe even in this during this pandemic. My name is Mr. ODEMENAM. Today, why I want us to do revision is because in the last exam, the performance was not good enough. And we need to review what we have done already so that when new topics are being taught, we'll be able to follow. If we don't make our foundation good enough, you will discover that you will not be making any headway in this area of science. Therefore, I will first, don't think that because I called it SS1, that means that if you are in SS2, you will not be able to benefit. Remember, while we are in school, usually if you are in second term, I will give you examination including your first term and your second term work. If you are in SS2, I'll give you the things you have done in SS1 and the thing you have done in SS2. Therefore, I will plead that those people that are in SS3, SS2 should come close. They will find that up to 30 or 40% of what I'm going to do in the revision today will be very relevant to them. They will discover that if I give this exam to them, most of you will not be able to score 70%, which means you still have 30% which you can learn if you are listening to this lesson this morning. Therefore, what I will do is, ordinarily, because some of you may not have the question papers with you, I'll be reading the questions slowly and be giving you the solution. And at the end of this lesson, I will give you the assignment to equally work out the 30 questions so that even if you are part of the lesson, you will discover that you will score out of the 30 questions, at least you will score up to 25. Because you must, and I hope you have your exercise books, your biro, and perhaps your calculator also. The first question here in section 1, which is objective, section A, which is objective. The first question says, why is an atom electrically neutral? Why is an atom electrically neutral? What we mean by atom being electrically neutral is that the atom have no charge. But if you know an atom an atom have a nucleus. In the nucleus, it consists of proton and neutron. Proton is positively charged. Neutron have no charge. Then in the periphery of the atom, in the circumference, you have an electron. An electron is negatively charged. Therefore, for an atom to be electrically neutral means that the number of protons must be equal to the number of electrons. That is why you have an atom being electrically neutral. For instance, you have sodium. If you look at sodium here, you will discover that sodium have 11 electrons. The electron is represented by this small 0. Then inside the nucleus, you have proton. And proton there is 11. This is sodium. And the electron there is also 11. Just like I've said before, I said that proton have positively charged, plus 11. This one is minus 11. Plus 11 minus 11 will give you 0. That's why an atom is electrically neutral. If it's hydrogen, hydrogen have one electron, and it has in the nucleus, you have one proton and one neutron. Then this electron is 1, which is minus 1. The proton is 1, which is plus 1. Plus 1 minus 1 is 0, which means an atom of hydrogen is electrically neutral. Therefore, the answer here is, why is an atom electrically neutral? You can write down, an atom is electrically neutral because an atom contains equal number of proton and electron. That is the answer for that number 1. Then number 2 says, I hope you are writing down what we have done and making your notes, putting down the sketches that will help you to understand it. Then the second question says, explain why magnesium has high melting point than sodium. How we are going to do that is that we must know the diagrammatic electronic configuration of magnesium and sodium. For magnesium, you know that magnesium has atomic number of 12. Sodium have atomic number of 11. Therefore, this is magnesium. Two electrons in the 1s orbital, 8 in the L shell, and 2 in the M shell. This is magnesium. Then you have sodium, which I have drawn before. Sodium, you have 2 in K shell, 8 in L shell, 1 in M shell. You discover that sodium have only 1 electron in the outermost shell. Magnesium have 2 electrons. You discover that these 2 electrons, they have negative charges, negative charges. You discover that in the nucleus, it has proton, which is positively charged. If you look at you know that opposite charges attract. This is negatively charged, this is positively charged. Because you have 2 negative charge here, the force of attraction will be stronger for this magnesium because it will attract it more stronger. And this one, it will be stronger than this one that have sodium that have only 1 electron. Which means that in magnesium, the forces that hold them together is very strong, more than that of sodium. Therefore, you see magnesium having higher melting point. Because you know that melting point is the temperature at which a solid melts. A solid is changed to liquid. And for that solid to change to liquid, it means that there must be a force that you add. This one that has stronger force of attraction, we need a higher temperature. This one that have less force of attraction, we have a lower temperature. That's why magnesium have a higher melting point than sodium. Let me rewind. The question says, explain why magnesium has high melting point than sodium. I've been explaining, but simply put, you will just say it has high melting point than sodium because it has 2 electrons in the outermost shell or 2 valence shell, while sodium have only 1 electron in the outermost shell or 1 valence shell. Then number 3. Number 3 says, why do elements undergo chemical combination? Why do elements undergo chemical combination? The answer to this one, you know that, let me explain combination. Combination is when 2 elements come together to form a new substance. And for it to form that new substance, there are two principal ways it will occur. It will either be by transfer of electron from one element to another, or it can be sharing of electron between two elements. The question here says, why do elements undergo chemical combination? Then write the answer. Elements undergo chemical combination in order to have a stable configuration. I will explain that on the board, but write down the answer. Elements undergo chemical combination in order to have stable configuration. Or if you like, you say in order to have octet configuration or duplet configuration. Let me give you an example, because it's not just giving you the answers that are important. The most important thing is for you to know that the answer is the right thing, for you to explain how you got the answer. For instance, let us look at how sodium combines with chlorine. You know that sodium is an element, chlorine is an element. You have done this thing. Let us write the electronic configuration using shelf configuration. Sodium is 2 electrons in the 1s orbital, 8 electrons in 2s and 2p orbitals, and 1 electron in 3s orbital. This is the electron configuration of sodium. Chlorine, you have 2 electrons in 1s orbital, 8 electrons in 2s and 2p orbital, and 7 electrons in 3s and 3p orbital. You discover that when we did sodium, look at sodium. This sodium atom, it has 1 electron here, 8 here, and 2 here. This is sodium. When sodium is going to react, it will lose this 1 electron, and the electron structure becomes this. You can see that sodium, when it's going to combine, will lose this electron. And when it loses this electron, this shell goes out. It's remaining 2 shells. And the reason why we're having minus here is because, in a sodium atom, it has 11 proton, which is plus 11. And 11, this is 11 proton, this is 11 electron, which is minus 11. If sodium loses 1 electron, it means that Na plus will now become 11 proton and 10 electrons. Therefore, plus 11 minus 10 will give you plus 1. I hope you have gotten it right. Plus 11 minus 10 will give you plus 1. Sorry. Please correct this. Here is not minus, it's plus. Since we have solved it here, we can see why. Plus 11 minus 10 will give you plus 1. Is it not true? I know you have corrected what the mistake we made before. You have seen that for sodium to combine with chlorine, sodium will lose 1 electron. And that electron that sodium have lost, chlorine will gain it. You see that chlorine is 287. Chlorine atom will have this. This is 287. This chlorine atom. When this chlorine atom gains 1 electron from sodium, it will give you this. Let me put it here where you see it very well. This chlorine atom. Then this chlorine atom, if it gains 1 electron from sodium, it will give you this. Let us represent the electron gained from sodium as X. You see that this one is 287, this one is 288. This is an octet configuration, 288. And this one is equally an octet configuration, 28. What type of bond is formed when there is a large difference between the negativity of 2 elements combining together? Let us use sodium and chlorine as an example. You will see that sodium will prefer to give out electron, while chlorine will prefer to accept electron. Therefore, in such circumstances, sodium is more electropositive than chlorine. Because sodium is more electropositive, you see that sodium is highly electropositive, while chlorine is highly electronegative. For when you have a combination that involves transfer of electron from an electropositive element to an electronegative element, you call that kind of combination ionic combination. Ionic combination or electrovalent combination. You call it ionic combination or electrovalent combination. Ionic combination or electrovalent combination. That is the answer for number 3. The number 3 says, what type of bond is formed when there is large difference between the electronegativities of 2 elements combining together? And I said that in such circumstances, there will be transfer of electron. Hence, you call it ionic combination or electrovalent combination. Number 5. Number 5 says, why is a tincture of iodine regarded as a mixture? I'll be a little bit faster. Why is a tincture of iodine regarded as a mixture? I know you have gone to a hospital before, maybe with a wound. When you have such wound, you see a nurse will come and clean it with water and then clean it with a tincture of iodine. That tincture of iodine is made up of iodine crystal. It's made up of iodine crystal plus ethanol. Ethanol is C2H5OH. You see that iodine crystal is a solid, while ethanol is a liquid. For why it is regarded as a mixture is because you can separate it by physical method. You can separate it by physical method. And that physical method is applied based on their boiling point. Therefore, if you heat it, ethanol will vaporize. You heat it slightly, ethanol will vaporize, while iodine will remain, crystal will remain. It's either you do it by ordinary evaporation to dryness, or you do it by simple distillation. That is a physical method of separation. Then, I hope you have gotten it right. Why is a tincture of iodine regarded as a mixture? I said that a tincture of iodine is regarded as a mixture because it can be separated into its constituent by simple physical method. And I said that the simple physical method is by evaporation to dryness or by distillation. Then number 6. Number 6 says, what is the mass number of an element having 20 neutrons, 15 protons, and 15 electrons? What is the mass number What is the mass number of an element having 20 neutrons, 15 protons, and 15 electrons? First and foremost, although I know you already know, but we need to know what mass number is. Mass number is the sum of proton and neutron in an atom. Which means if we are saying mass number is equal to protons plus neutrons. And in our question here, we have seen that the number of proton is 15. And the number of neutron is 20. That gives us 35. For the mass number of that element is 35. Mass number have no unit. Mass number have no unit. Then number 7. Number 7 says an element Y an element Y with electron configuration 1s2, 2s2, 2p6, 3s2 belongs to what group and period? An element Y. Element Y with electron configuration 1s2, 2s2, 2p6, 3s2 belong to what group and period? I will solve this in 2 methods. First, let me solve it with what we have here already. If I'm solving it with what we have already here, this thing is your K share. This 2 is your L share. This is your M share. And this M share is your atomose share. Which means this element Y belongs to group 2 because it has 2 electrons in the atomose share. Group 2. And if you look at what we have done, you see that this K share is represented by a quantum number 1. This L share is represented by a quantum number 2. This M share is represented by a quantum number 3. Because this one is 3, the maximum here, the period is 3. But usually when we are writing group, instead of writing 2 this way, we use Roman figure with a bracket. But this one will use 3. If I don't want to do it this way, but this is the simplest way you can do it, you change the electron configuration from SPD notation to shell configuration. And if you are changing it to, because if you look at this, you see 2 plus 2, 4, plus 6, 10, plus 2, 12. If I want to change it to shell configuration, the configuration will be 2, 8, 2. You see that this is 1, this is 2, this is 3, the third shell. Therefore, it has a group 2 and period 3. That's how to solve this. Maybe let me just give, for example, if you go to sodium that we have just mentioned before, which we say is 281. You see that sodium is in group 1 and in period 3. Then number 8. Number 8. Number 8. Number 8 says, an element Y has an atomic number 9. An element Y have atomic number 9. What is the most likely oxidation number in its binary compound? Well, there are certain things we need to explain here, because it's true that we are doing revision, not just giving you the answers, but explaining how we got about the answer. How we got the answer. It says an element Y has an atomic number 9. What is the most likely oxidation number in its binary compound? We need to know what is oxidation number. We need to equally know what is binary compound, because it is these two things that will help us to be able to answer the question. Oxidation number is the charge an element have or appear to have. Is the number an element have in a compound or appear to have. Let me give you an example. You know that when we have sodium chloride, you discover that when we did sodium, we said that it has +1, if you can still remember. And when it's reacting, it will lose 1 electron and it becomes +1. And chlorine, when it's reacting, it gains 1 electron and becomes -1. You see that these are the charges they have. You can now say that sodium have oxidation number of +1 and chlorine have oxidation number of -1. I would like to tell you, when you talk about oxidation number, the number must have a charge. You cannot say oxidation number of sodium is 1. No, it's not correct. You cannot say oxidation number of chlorine is 1. It's not correct. You must put the charge. Therefore, I've said that oxidation number is the charge an element appears to have or have in a compound. For let's look at what is binary compound. By now you would have known what a compound is. A compound is a substance containing 2 or more elements chemically combined together. Therefore, if you have a binary compound, it means that it must contain only 2 elements. Therefore, the question now is that an element Y has atomic number 9. Therefore, the first and foremost, we put this as the electronic configuration. It becomes 2 in K shell, then 7 in L shell. You see that the atomos shell here has 7 electrons. And since it has 7 electrons, it means that the oxidation number will be negative. because it will accept one electron to become 2,8. Therefore, the answer here, so that we don't take so much time, is -1. This element must be a non-metal, and a non-metal combined, especially with metal, when it accepts electron. What is the IUPAC name of this compound? FeO4. For us to answer this question, but I'm not going to go far in saying it, we should know the oxidation numbers of the element or radical in this compound. You look at this, is a radical. This radical have oxidation number of -2. This element, ion, have oxidation number of +2. Based on this, and before now, we should know the names of the radical and the element in this compound. The element in this compound is ion, ion 2, and the radical in this compound, which is SO4, is tetraoxosulfate 6. Therefore, the name of this IUPAC name is ion 2 tetraoxo, meaning that it contains 4 oxygen. Tetra is 4. You know that mono is 1, di is 2, tri is 3, 4 is tetra. Tetraoxo, oxo, because of this oxygen. Sulfate 6. This SO4 is sulfate. For this is the name, ion 2 tetraoxo sulfate 6. Great student, we have come to the end of this lesson. We have attempted the second term question for 2019-2020 exam from number 1 to number 9. And while we are doing it, we are not only providing the answers, but explaining how the answers was arrived at. I'm giving you the assignment. Your assignment will be, especially if you are in SS1, even when you are in SS2, you have brothers, you have sisters, people who are around you that you can get the question paper and solve the remaining from 10 to 30. Perhaps when we come next, we will review it so that when we are reviewing it, we will not take so long time. Or possibly, if you submit the answers, after marking them, I will know the numbers that are difficult for you, and we will discuss it when we come next. Bye for now. Please keep safe as you stay at home during this pandemic. May God bless you in Jesus' name. Amen.